So what if I told you that the reason your AI outputs sound like a robotic, I don't know, high school book report
Hmm.
isn't actually because the technology is flawed?
Right. It's actually because you're treating a supercomputer like a basic search engine.
Exactly. And welcome to today's deep dive. We are super thrilled to have you here with us. Today we are looking at a really fascinating training module called Project XM Lesson A3.
Yeah, and even though it's a curriculum originally aimed at construction professionals, the principles inside it apply to literally anyone who uses artificial intelligence in their daily work.
Oh, absolutely, everyone. So let's
Yeah.
just get right into it. Because the core message of this module is, well, it's kind of a stark warning, but also a massive promise.
It really is. The warning is just that the way most of us currently interact with these tools is fundamentally backwards.
Right.
But the promise is that by making just one specific mental shift, you can unlock a totally different level of capability.
Yeah, and the exact phrasing this training uses, which I love, by the way, is stop prompting, start engineering.
Stop prompting, start engineering. Yeah, it's so perfectly put.
Okay, so let's unpack this for the listener.
Yeah.
Because if you have ever, sat there staring at a blinking cursor, feeling like you're just battling the machine to get a decent result.
Oh, shaking it like a magic 8 ball.
Exactly, shaking it and crossing your fingers. If that's you, this deep dive is going to completely change how you approach your workflow. We are talking about the difference between hoping for a mediocre outcome and engineering a guaranteed, highly professional one.
Yeah, but to do that, it really requires unlearning a habit we've all built over the last 2 decades. We've been trained by search engines to just type in a quick question and expect a perfect answer.
Right, like Googling something.
Exactly. But an AI model is not a search engine looking up a database. It's a pattern matching engine generating text based on probabilities.
Probabilities, right.
So when you just give it a basic prompt, like a simple question, you're basically starving it of the parameters it needs to form the right pattern.
So you're saying a basic prompt just isn't enough information for it?
No, not at all. Context engineering, on the other hand, is the deliberate design of the entire environment the model sees before it starts generating a single word.
The environment.
Yeah.
That is such a huge distinction. Not just the question, but the actual, room you are putting the question into.
Yes, that distinction changes everything. You are designing the persona, the constraints, the background information, the specific formatting requirements. You're giving it an entire world to inhabit.
Which is wild to think about. The training module actually gives a fantastic example of this from the construction sector, right? Drafting an NCR or a non-conformance report.
Right. And for anyone outside the industry, an NCR is basically the formal paperwork you file when something on a job site gets built wrong or, fails an inspection.
Super standard stuff. But if you just open up your AI tool and say, write an NCR, the AI is essentially operating blindfolded.
Completely blindfolded.
It's just going to spit out a generic, empty template filled with placeholders and, I don't know, corporate fluff.
Yeah. And the output is generic because the input was generic. But a context engineered approach looks entirely different.
Right.
Instead of a 3-word command, you define its role. You say, you are a senior quality inspector.
Oh, I see.
You feed it the specific project background. You maybe even reference the exact inspection and test plan that was failed. You include the subcontractor's name, describe the specific physical defect in detail, and outline the remediation.
Wow. Okay, so when you surround the task with that much detail,
Hmm.
the model doesn't even have to guess what you want. It just executes.
Exactly.
I love thinking about it through a slightly more everyday lens. Like if I walk into a restaurant, sit down, and just tell the chef, make me dinner.
Oh, that's a gamble.
It's a massive gamble. That's a basic prompt. I might get a beautifully cooked steak, or I might get a bowl of cold cereal. It depends entirely on what the chef assumes I want.
Right.
But if I give that same chef my dietary restrictions, my exact flavor preferences, the specific ingredients I absolutely want avoided, and like a picture of the exact plating style I'm looking for, that's context engineering.
That restaurant analogy hits the nail right on the head. But here is where it goes one step further with AI. When you just say, make me dinner, you are shifting all the cognitive burden onto the chef to basically read your mind.
Yeah, which is unfair to the chef, really.
Right. And historically, so-called prompt engineers have spent a lot of time trying to figure out clever tricks or like magic phrases to manipulate the machine into reading their minds.
Right, the magic words.
Exactly. But context engineers don't do that. They take the responsibility upon themselves to build a comprehensive environment that eliminates the need for the AI to make assumptions in the first place.
Which makes perfect sense. I mean, if you remove the guesswork, you naturally remove the hallucinations and the robotic fluff.
Yeah.
But that brings up a really practical problem for you listening. If the goal is to build this robust environment, how do we actually do that consistently? I mean, I want to make sure I'm not accidentally leaving out a load-bearing wall that causes the whole thing to collapse.
Well, there is a very specific architecture for this, and it's built right into the ProjectXM module. They use an acronym called RASCE. That's RASCEF.
Frassius.
Yeah, and it functions as a blueprint to ensure you construct that environment reliably no matter what task you're trying to complete.
Let's break that acronym down, because I think understanding the mechanics behind these letters is where the rubber really meets the road here.
Let's walk through it. So the R stands for role. Who is the model pretending to be? Are they a senior copywriter, a meticulous data analyst, or a legal advisor?
Okay, just to pause on that real quick. Why does role actually matter? Does the AI really care if I tell it it's a senior copywriter?
Oh, it matters deeply. Yeah. Because of how these models are trained, they map language mathematically. So when you assign a specific role, you are mathematically pointing the AI toward a specific cluster of vocabulary and tone in its training data.
Oh, wow.
Yeah, a senior copywriter uses very different word vectors than a first-year intern.
That is fascinating.
Oh.
Okay, so what's next?
Next is A for audience. Who is this output for?
Same mathematical logic there, I imagine. Like, writing for a CEO requires a different structural pattern than writing an email to a frustrated customer.
Yes, exactly. And that brings us to S for situation. This is the broader context. What led to this request? What's the background story?
Right, the setting the scene part.
Yeah. And then we have C for constraints. This is arguably where a lot of people trip up. Constraints dictate what the model must absolutely do or definitely not do.
I can completely relate to that one. I can't tell you how many times I've asked an AI to summarize a quick article for me, and it spits back a 10-page novel.
Right.
If I just added the constraint, do not exceed 3 bullet points, I would have saved myself 10 minutes of reading.
Exactly. Constraints are the guardrails. Moving on, E is for examples, showing the model what success looks like rather than just describing it.
Oh, I like that. Show, don't tell.
Precisely. And finally, F is for format. Do you want an email, a markdown table, a Python script, a formal letter?
Okay, so let's look at how this module applies the whole RASCEF blueprint to a real-world scenario. They use the example of drafting a disputed variation notice, right?
Yeah, so basically you're on a construction site, extra work had to be done, and now you are formally arguing over who is paying the extra costs.
Sounds stressful.
Oh, it is. But if we use the framework, you don't just say, write a variation notice, you give it the role. You are an expert contract administrator.
Okay.
The audience, a legally trained principal. The situation we're operating under the AS 4000 contract framework.
The constraints, maximum 300 words, and no unnecessary legal jargon.
Exactly. And the format 3, specific paragraphs breaking down the facts, the entitlement, and the quantum.
Let's quickly translate some of that industry terminology for anyone unfamiliar, because AS 4000 is simply a widely used standardized construction contract in Australia.
Yeah. By naming it, you are telling the AI exactly which set of legal rules apply to the situation.
Got it. And quantum is just a formal term for the actual dollar amount or financial cost being claimed.
Right.
But even knowing what those terms mean, notice how radically different that input is from our initial Magic 8-ball approach.
Oh, it's night and day.
You have boxed the AI into a highly professional, incredibly narrow corridor. It literally cannot stray into generic fluff because you have built absolute boundaries around it.
It completely changes the probability calculation of the next word it generates.
Okay, but I'm going to push back a little bit here on behalf of anyone listening, because this sounds, well, exhausting.
Seriously. Do I really need to fill out a 6-part, highly detailed dossier every single time I want the AI to write a quick email to my team or, like, summarize a weekly report?
Yeah, no, I get that.
It just feels like it would take me longer to write out the RASCEF prompt than to just type the email myself.
That is a completely fair pushback and honestly a very common reaction, but the short answer is no. You do not need to use every single element for every minor low-stakes task. Think of the RASF framework like a commercial pilot's pre-flight checklist.
Okay, a pre-flight checklist. Walk me through that.
Well, a pilot flying a massive jet from New York to London doesn't just jump in the seat, turn the key, and hit the gas, right?
Definitely not. I hope not, anyway.
Right. They go through a rigorous, standardized checklist. They check the hydraulics, the fuel pressure, the comm systems.
Yeah.
Why? Because missing one critical element at 30,000 feet results in a catastrophe.
Makes sense. Now, if you are just driving your car down the street to get groceries, you don't do a pre-flight checklist. But when you are doing high-stakes professional work with AI, drafting a binding contract, writing a critical incident report, analyzing sensitive financial data, RASF, ensures you don't miss a load-bearing wall that could derail the entire output.
I see.
You run through it mentally. Do I need to specify a role here? Yes. Do I have clear constraints? Yes.
Yeah.
Eventually, it just becomes muscle memory.
That reframes it perfectly.
Yeah.
You deploy the heavy machinery when the task demands it. So now we've built this massive environment with all these rules, but the training module actually reveals that not all the letters in that acronym carry the same weight.
No, they don't.
There is one specific letter that does way more heavy lifting than the rest combined.
The E examples. In the AI industry, this is formally known as few-shot prompting, and it is consistently the most powerful addition you can make to your environment.
The module makes a really bold claim here. It says one good example is worth 100 words of descriptive instruction.
It is the ultimate application of show, don't tell. Let's say you want the AI to write a memo in your company's specific corporate tone. You could spend 3 paragraphs trying to describe that tone, right?
Right.
You might write, be professional, but slightly casual. Use the active voice. Don't be too rigid, but also don't sound like a teenager.
And the AI still gets it terribly wrong.
Oh, always.
It ends up sounding like a robot trying to ride a skateboard. It's incredibly awkward.
Right, because adjectives are subjective. Casual means something entirely different to everyone. But if you skip all those adjectives, paste in a previous memo that your boss actually loved, and tell the model, use this exact format and tone for the new task, it will perfectly mirror your standard work product.
That completely shifts how I think about this. It's not about giving the machine a vibe. It's about giving it a mathematical anchor.
A mathematical anchor.
We have this tendency to treat AI like it's an omniscient supercomputer from a sci-fi movie. We assume it intrinsically knows what we mean by professional.
Yeah, but it doesn't.
But according to this training, it actually learns best like a brand new human intern on their very first day.
Yeah.
You don't give the intern a philosophical lecture on the company's brand voice. You just slide a folder across the desk and say, make the new report look exactly like what the person before you did.
Exactly. The underlying psychology, or rather the mechanics of the machine here, are really fascinating.
Yeah.
AI predicts the next most likely word based on the mathematical weights of its training data. So when you try to describe a tone using words like professional or casual, you are giving it a very broad, fuzzy vector space to play in. It has millions of potential pathways.
Lots of room to mess up.
Exactly. But when you provide a specific real-world example, you aren't just giving it a helpful hint. You are locking it into a highly specific mathematical pattern. You narrow its universe dramatically, making its output exponentially more reliable.
You are literally fencing in its probabilities.
Yeah.
Okay, so providing a great example fixes the style. It nails the tone and the format perfectly.
Right.
But what happens when the logic of the task itself is incredibly complex? Let's say it's not just about sounding right, but it's about actually solving a multi-step analytical problem, where one wrong assumption early on ruins the entire conclusion. How do we stop the AI from making careless analytical mistakes?
This is where we transition from just setting the scene to actively forcing the AI's cognitive process. The technique for this is known as chain of thought.
Chain of thought.
Yeah. For complex, multi-step problems, you must explicitly instruct the model to think step by step before it delivers the final answer.
Literally just giving it the command, think step by step.
Yes, or designing a specific sequence for it to follow. The difference it makes in accuracy is honestly staggering.
Really?
Yeah. The training module uses the example of an EOT, an extension of time entitlement.
Right.
Briefly, this is a complex construction claim where a contractor asks for more time to finish a project because of a delay out of their control. If you just prompt the AI with draft an EOT notice, the model will try to jump straight to the finish line and draft the final letter.
And in doing so, it often skips crucial logical steps, leading to a weak or legally flawed claim.
Because it's prioritizing generating a letter over doing the underlying analysis.
So instead of letting it rush to the end, you force it to pause.
Precisely. You instruct the model. Before drafting the notice, I want you to first identify the delaying event. Then, establish the causal link to the delay. Then, identify the specific entitlement clause in the contract. And finally, calculate the exact number of days claimed.
Oh, wow.
You command it to output all of that analysis first, and then, only based on that analysis, draft the final notice.
So is this essentially forcing the AI to show its math homework on the chalkboard before it's allowed to write down the final answer at the bottom of the page?
That analogy is spot on. And think about why math teachers make you show your work.
Because they enjoy torturing us.
Well, besides that, it's because the physical act of writing out step 2 ensures that the calculation for step 3 is actually correct.
Right. If you try to do a complex algebra problem entirely in your head, you drop a 0 somewhere and fail the test.
AI architecture works in a remarkably similar way. Large language models have a context window, which is essentially their short-term memory.
Okay.
When the AI generates the text for step 1 and step 2, those specific generated words physically enter its short-term memory. It literally reads its own reasoning.
Wait, really? It reads what it just wrote?
Yes. That newly generated logic becomes part of the environment for step 3, which grounds its final output in structured deduction rather than just probabilistic guessing. It replaces the AI's tendency to hallucinate with a rigid framework of logic.
That is incredibly powerful. You're not just telling it what to output. You are actively managing how it processes information.
Exactly.
But let's be totally real for a second. Let's say I do everything right. I use the RASEF checklist. I give it a brilliant few-shot example. I force it to use chain of thought logic. And the output still isn't quite right.
It happens.
Maybe it's slightly too long. Or it missed one tiny nuance about the project timeline. What then?
This brings us to the final and perhaps most crucial piece of the puzzle. The module refers to it as the master skill targeted iteration.
Targeted iteration.
Expert context engineers do not ever expect perfect output on the very first try.
Wait, really? Even after building this meticulously engineered environment?
Even then. Because human language is inherently fluid and complex, the true mark of a professional is not writing a flawless, magical first prompt that solves every problem simultaneously.
Right.
The real skill is looking at the slightly flawed output and knowing exactly what single lever needs to be pulled to fix it.
I think this is a huge realization for a lot of people because most of us get a bad result, we read it, we get frustrated, and we either give up and just write the document ourselves or we delete the whole chat window, curse at the computer, and start completely from scratch.
And deleting the chat window is the absolute worst thing you can do.
Why? I feel like I'm clearing the board, a fresh start.
Because of that short-term memory, that context window we just talked about, when you delete the chat, you are giving the AI total amnesia. Ooh, you are throwing away all the valuable context, constraints, and background rules you just spent time building. The golden rule of context engineering is do not start over. Identify the specific gap in the output and refine just that one element within the same conversation.
The training module actually provides some wonderfully practical examples of this iteration in action. Like, if the output comes back and it sounds incredibly stuffy, like a lawyer from the 1800s wrote it.
You don't delete everything and start over.
Right. You just type into the same chat, refine this, write plain technical language.
Exactly. Or if you read the draft and realize it didn't include a date for when the defective work needs to be fixed, you just add a new constraint. Always include a specific deadline for remediation.
Wow.
If it gave you an absolute novel and you just needed a summary for an executive, you just add refine, maximum 200 words.
You are literally just tweaking the dials on a control board, dialing it in closer and closer to what you need.
Yes, you are iterating. The module emphasizes that interacting with AI is, by its very nature, an iterative process. You have to treat the AI like a collaborative partner, not a vending machine.
A vending machine. I like that.
Yeah, you don't just put your coin in, press a button, and kick the machine when the wrong candy bar comes out. You converse, you guide, you refine. The second version is always better than the first.
Always.
And the third version is usually exactly what you need. That patience for targeted refinement is what separates casual users from professional context engineers.
I love that framing. A collaborative partner, not a vending machine. That perfectly captures the massive shift in mindset we've been talking about today.
It really does.
So let's quickly recap the absolute essentials for you to take away from this deep dive into ProjectXM Lesson A3. Number 1, stop treating AI like a basic search engine. Start designing comprehensive environments.
Right.
Use the RASEF framework role, audience, situation, constraints, examples, format, as your pre-flight checklist so you don't crash the plane before you even take off.
Absolutely.
And remember that the E for examples is your secret weapon. One good example mathematically locks the AI into the pattern you want.
And number 2, never let the AI skip to the end on complex tasks. Force it to show its math homework on the chalkboard using chain of thought reasoning so it actually reads its own logic before giving you a final answer.
And number 3, never delete the chat window in frustration. Protect that context window. Iterate. Tweak the dials. Assume the first draft is just the starting line.
Such good advice.
So, having digested all of this, what does this actually mean for us? How does this change the way we interact with technology moving forward?
Well, this raises an important question, and it's something I've been analyzing deeply since reviewing this curriculum. The material clearly proves that to get the absolute best out of AI, we must meticulously engineer the context.
Right.
We have to clearly organize our constraints. We have to be hyper-aware of our specific audience. We have to define our logic paths step by step with absolute clarity.
We have to become incredibly deliberate communicators.
Yes, perfectly structured and logical. But here's the fascinating twist. If we are forced to operate at that incredibly high level of clarity just to get the machine to work properly, are we simply programming the AI? Or, by demanding this rigorous level of precision from us, is the AI actually reprogramming us to become better, clearer, more effective professional communicators?
Wow. That completely flips the script.
Yeah.
Are we training the machine, or is the machine subtly training us to stop being so vague and sloppy with our own words?
It's definitely something to think about.
That is a brilliant thought to leave on. Think about that next time you stare at that blinking cursor. Next time you're tempted to just type, "make me dinner,"
Yeah.
pause. Build the environment. Be the context engineer. Thank you so much for joining us on this deep dive. Take that question with you into your next project, and we will catch you on the next one.